Okay, today I want to show you how to write chemical formula or formulae of binary compounds. A binary compound is any compound that is made up of two elements only. Now here are some few examples. It says write the chemical formula of the following binary compounds. The first one is sodium oxide. If you want to write this chemical formula, that the first one is sodium oxide, you first of all consider the symbol of the elements present. Here, the elements present include sodium and oxygen. Oxide stands for oxygen, please. So you write Na for sodium and O for oxygen. Number two, consider the oxidation numbers, the oxidation number of sodium and the oxidation number of oxygen. Sodium is +1, oxygen is -1. How did I get +1? +1 is gotten from the electronic configuration of sodium. Sodium has an atomic number of 11. If you recite the first 20 elements, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, the 11th element. So this is for sodium. The configuration becomes 2, 8, 1. It therefore means that it's going to be an electron to acquire a positive charge. Whenever an element is donating or giving out electrons, it acquires a positive charge. Whenever the element is receiving, it acquires a negative charge. Here, because sodium has 8 electrons in its outermost shell already and has extra 1, this one electron that it has extra as its valence electron can easily be given out. As it gives out this electron, it acquires a positive charge of +1 because it is giving out just 1. Now that of oxygen, oxygen has an atomic number of 8. The configuration becomes 6 rather. What does it mean? It means that if this is the structure of oxygen, electronic structure of oxygen, this is 6. It means it will receive extra 2 electrons to reach the maximum 8 electrons in its outermost shell. So as it receives 2 electrons, it acquires a negative charge. Whenever elements are receiving electrons, they acquire a negative charge. Whenever they are giving out electrons, they acquire a positive charge. Elements can acquire a maximum of 3 electrons. They can give out a maximum of 3 electrons. Now, since oxygen is acquiring 2 electrons, its charge becomes -2. Now, step 3, the last one is, if both charges are not the same, if they are unequal, you have to do the exchange of ionic radicals. In other words, you do an exchange of oxidation numbers. Here, sodium will be Na times 2, like this. Sodium takes this 2, oxygen takes this 1. So Na times 2 gives us Na2. 1 times O gives us O. So this is the chemical formula of sodium oxide. The next one is potassium chloride. As usual, symbol of potassium and symbol of chlorine. Oxidation number of potassium follows the same step that I gave to you here. It is +1. That of chlorine is -1. How did I get +1? +1 is gotten from the atomic number and electronic configuration of potassium. Potassium has an atomic number of 19. If you check the configuration, it will give you 2, 8, 8, 1. Here, it will be giving out 1 electron to acquire a positive charge, and that is how we got this +1. Chlorine has an atomic number of 17. The configuration becomes 2, 8, 7. Here, it will be receiving 1 more electron to become 2, 8, 8. So it will be -1 because it is receiving. This is what you need to note. When both charges are the same, when they are equal, when they are the same, you have to cancel out. This is +1, please. You cancel them out and bring both symbols together. So for this reason, it becomes KCl as the chemical formula of potassium chloride. Now finally, we have that of ion 2 sulfide. Ion has a symbol Fe. Sulfur has a symbol S. Ion 2, these 2 in bracket means that the oxidation number of ion has already been given to you, so you don't need to look for it. So it is +2. Sulfur, you have to look for that of sulfur. Sulfur has an atomic number of 16. The configuration becomes 2, 8, 6. What does this show us? It means that it will be receiving 2 extra electrons to acquire the octet electronic structure. Octet electronic structure means having 8 electrons in the outermost shell. And don't forget that number of electrons in the outermost shell are also referred to as valence electrons. So here you have your -2 because it will be receiving 2 extra. If this is it, it means that sulfur will be receiving just 2 extra electrons. So this is a 286. Here to receive extra 2 electrons to become -2. Again, when both charges are the same, you cancel them out, bring both symbols together. So this is the formula of iron 2 sulfide, FeS. Okay, quickly give me the formulae of this compound. Quickly in the comment section, write down the chemical formula of the first one, chemical formula of aluminium oxide, and the chemical formula of lead 2 chloride, of lead 2 sulfide. Click the follow button for more.